Hi, welcome to the Keys podcast with Victor Chemartin and engineer Kirk Kofi. Nice to meet you.
Nice to meet you, Victor.
We are pleased to have Mr. Kofi with us here today. He's the former CEO of the Volta River Authority, and he's going to talk to us about Ghana's energy industry and all things energy today, especially the interesting topic of Dumsor. Hi, Mr. Kofi. How are you doing today?
I'm doing very well, by His grace.
Thanks. So we'll get right into it. Could you tell us a little bit about yourself and maybe your background growing up?
Well, if you want to go from the beginning, I'm sure the show will not end today. I went to the University of Science and Technology. At that time, it was University of Science and Technology. And I came out with a degree in mechanical engineering in 1981. And by His grace, luckily, I was posted to VRA. What I don't know is whether I chose to go to VRA or I was posted. But what I know was I was just sent to VRA on national service in 81. And the moment I landed at VRA, I was impressed with the place. The professionalism and the idea that VRA was one key and very vital institution in the country. I made up my mind from day one that, well, I'm going to spend my life in this company. And I keep on telling people that, oh, well, this company, I'm going to stay here and never go anywhere. But that was during the time that people were going to Nigeria. So I purpose in my heart that I'm going to stay here, work, and make sure I rise to the top. At that time, my imagination of the top was the director in Kosovo. So I stayed in VRA. After national service, I was employed as an assistant engineer in 82. And by His grace, one thing I can say is that I moved through the various ranks in VRA to the very top. From assistant engineer to engineer, then I was in a Kosovo plant, worked there for a few years, then taken to pump plant. That's when the pump generating station was completed. And so I was like close to the first batch of people who worked there. So from pump generating station, I was taken back to Kosovo again as an engineer who worked on a retrofit project. I came back to pump generating station as a plant manager. And then as a plant manager, at Pond Generating Station, I was moved back to Kosovo as a plant manager. I'm telling you all this because I moved through the various ranks. There was no shortcut. Plant manager at the Kosovo Generating Station, director of hydro generation. And then from director of hydro generation, I became deputy chief executive of VRA in 2008, June 2008. And I was deputy chief for 2008 to 2013. And it was 2013 that I was privileged to be appointed into the role of the chief executive of VRA, a position I held for 3 years till there was a change in government. And of course, when there's a change in government, some of these high-level positions are replaced. So I was replaced in I think end of February 2017. So I've been in VRA from 81 to 2017. So that's been all my life. Never worked anywhere, but it's been quite exciting because VRA's role is to produce electricity to help developing the country. And for me, if you know the importance of what you do and its effect on the development of the country, you are proud. And that's the little I can say about it. I'm sure I have to go on. I mean, I'll get a chance to talk more about other things. But it's been quite exciting and quite fulfilling. I mean, as a human being, as a professional engineer. And VRA is one good place that I always recommend for anybody who wants to get a fulfilling engineering practice to go there. But not only engineering, the VRA has other units, and as we go along, we can talk about those things. The other units do also work professionally.
That's an amazing story of determination and commitment. I mean, being in a company as important as VRA, as probably as high pressured as VRA, from national service to CEO, that's really unique. Really unique, and it's great to hear that you found it a fulfilling journey as well. And could you tell something to our viewers or those watching? What does it take to have, or how do you build the fortitude to be committed to your craft or your career, even especially within one company?
The individual comes in. You as the person should be determined that, well, I want to make my life here. I want to make my career here. I want to live here. And, well, no shortcut, as I said. You should be working well to be able to progress. If you joke with the work, there's no way you can progress, I can tell you. If you joke with the work, there's no way you can progress through the various ranks. You have to like your work and do your work and do it well. And everybody will see. Because if you don't do it well, you can't move from one level to the other level. And as I said, I was more determined about making sure that whatever VRA stands for succeeds. Okay, so as a result of that, well, I was able to do whatever it is. And VRA is a good company. I mean, you enter as one level, you are developed along the line. Extra, I've been taken to other schools. I mean, you are developed at the line as you move ahead. So that's why I say it's a well and established institution, very fulfilling, and it's still doing the same. I mean, I'm sure you could meet other people who's also gone through the system that way, who can also say the same thing I'm talking about right now.
Yeah, that's it. Thank you very much for that. So I'd like you mentioned that you were head of hydro generation, and I mean, like, I'm sure for the layman, they may not know exactly how VRA fits within the larger power generating ecosystem in Ghana. Like, as VRA, how is it connected to Crude Oil? Yeah, if you could just give us kind of.
That's a very good and intelligent question. VRA, several years back, was established by the first president, Kwame Nkrumah. Until then, we have the electricity company of Ghana. But then the VRA came in when a Cosmo plant was built, okay, through the Water River project. So VRA came in 1962. And to be honest with you, this year marks April will be VRA's 60th anniversary. So current management and executive are having preparations to celebrate that.
Congratulations.
So VRA, until 2008, was the main generating company of electricity and transmission. VRA was doing generation and transmission. It was 2008 that the transmission aspect of the business was moved into a subsidiary, was moved into another company called Gridco. There was a reason for that, because, well, the reason being that we're trying to attract other IPPs into the sector, and VRA cannot be a player and also manage the transmission. So the transmission aspect of VRA was separated into a separate company called Ghana Grid Company, so that they can effectively transmit power from whoever is the producer. Okay, so that was in 2008. But till 2008, VRA did all the generation, transmission all over the country, and then the distribution of electricity in the northern part of the country, NECO, is a subsidiary of VRA. I think government found it wise when government decided to send electricity to the northern part of the country in the later part of the 80s. That subsidiary, instead of going to ECG, I don't know, government found it wise to make sure that, I think they saw the performance of VRA and they didn't want to saddle ECG too much with that. So VRA was very instrumental in one, you transmit the power to the place. So if you are transmitting the power to the place, you might as well also do the distribution. And I think VRA has relatively and have done that business very well. So the distribution of electricity in the northern part of the country, that's anything above Ashanti region. So Brongafu, Northern, Upper East, Upper West, now we have Bono and other regions, have been the responsibility of VRA since the late 80s. Okay, so today VRA is only a generating company. So VRA has a Cosmo generating station, which is a 1,020 megawatt station. A plant was built in 1962, commissioned in 66, and then there was an expansion project which was finished in 72. And VRA, a Cosmo plant has been a main generating plant in this country, and it served the country very, very well. I mean, at the time it was built, they used to say it was one of the biggest hydro plants in the world, biggest man-made lake, providing all sort of activities in the country. And in 1976, 77, that's where the pump project was started. Okay, by then under the Achampon regime. The pump project was finished in 81, commissioned by His Excellency Rollins. He was then the head of state in 1982. That time I was a young engineer in VRA then. So 1 year was commissioned in 82 and added on to Akosombo as the two main generating station. 1 year is just 30 kilometers downstream from Akosombo, and we call it a run of the river plant from yeah. So the water coming out of Akosombo is what is used there to also generate electricity. It's a very important plant, and I always tell people when I was working there that one of the most, at that time, that was the most, I think the most expensive Ghana government project. It was $250 million at that time. And I think that plant was also well built because we had already built Akosombo, managed it for a number of years. We had experience. So building this other one, which is very close to the place, we use the experience of engineers and everything to master, to come up with that project. So that was finished in 82. It ran very well. And then along the line, it became necessary. I'm sure Dumsor will come. Along the line, it became necessary due to development in the country and other considerations why we could not depend only on hydro. It became very necessary for us to add a thermal complementation to our generating mix, because the first time in 83, 84, when we had drought, the lake level went extremely low. It became very difficult for us to supply the demand of this country, let alone, even though the demand at that time was very low. Okay, but that's where we felt about that it was necessary for us to add on thermal generation, even though at that time, I believe there had been a various school of thoughts. People thought thermal generation was a bit expensive, we could not afford because we did not have the gas, we did not have the crude oil in the 80s to add those thermal generations. So a lot of studies went into, and then management thought it's wise to add thermal generation. So with all the discussions and the challenges we had, I think in the late 90s, 98 or thereabout, we had to add some thermal generation in Takoradi where we build through government. VRA is a wholly owned government institution. So through government support, the Takoradi thermal plant was built. It's 330 megawatt combined cycle facility. Later on, through government support also, the Takoradi 2, which is a joint venture between VRA and an American company, which we call C.E.O, that is also been built. So in Takoradi alone, we have, at that time, we have 550 megawatt. The C.E.O plant was also enhanced into combined cycle. So in Takoradi alone, we had 550 then, later it got to 660. So that is what it is. So VRA does the generation, C.E.O does the transmission. So all the transmission network in the country goes to C.E.O. Then ECG does the distribution down south, that's Ashanti region and all the other regions. And then VRA does the distribution in the northern part of the country. And VRA has been exporting power to Togo, Benin ever since early 70s. Because at the time, that was the master plan to make sure, well, the every countries also benefit for that. Of course, the quantum of power transported at that time wasn't that much. Okay, so VRA was also had been sending power to Togo, Benin ever since then. Now we're sending power to Burkina Faso, large quantities. We had interconnection with La Côte d'Ivoire, Ivory Coast. Okay, interconnection with La Côte d'Ivoire. That was late 80s when that interconnection was done. I remember very well working on that project in Pristia when they had to build the 220 kV line from Pristia to from Abobo to Pristia, and we had to work on the synchronized connections then. Quite exciting. So all these things went on, and today we have a robust energy sector. It could be better, but looking at where we started from, I think we have a robust energy sector. And along the line with the restructure of the energy sector, we have the regulators, we have the Energy Commission coming in, we have the PURC also coming in as all part of regulator, and then we have the consumers and whatever it is.
Thank you so much for that very detailed explanation. So just to summarize, we have generation,
yes,
transmission, and distribution.
That is correct. What it is that you generate at the plant, and then you have to transmit on a very high voltage to reduce losses. So from our Cosmo, for example, we transmit from our Cosmo at 161 kV, and you can, if you notice, there are various substations all scattered around the country. One of our biggest substations is at Volta. That's the name they gave it. Volta. Then from there we have Achimota, and then Achimota substation, and then we have one Winneba. There's a substation in Cape Coast, and there's a substation in Takoradi, and then there's a substation in Kumasi. There's a substation at Pristia, Obuasi. You know, like any load center, there's a substation in the Volta region at Asiekwe. There's a small substation at Aflao. If you go, there's a big substation in Sunyani, Techima, Boga, and Tamale. We have substations. So you transmit at a very high voltage, at that time 161, to all these locations, and then it goes to ECG at 33 kV. Okay, then from 33 it can go to 11 kV and then come to your house at 415. So that is what it is. But along the line, having until not too long ago, we had all 161 kV at the highest voltage of transmission. Our interconnection with Togo, La Côte d'Ivoire, was 225 kV. You know, if you want to send power over a long period, you send it at higher voltage. Yes, it makes sense to do that, reduce the losses. And then later on, through studies, we had to then build 330 kV lines, 330 kV lines. So we have a 330 kV line from Boise all the way to Volta. We're building, I say we, as if I still work in VRA. There's a 330 kV line from Takoradi all the way to Boise to Kumasi. There's a connection to also take it all the way to the north, and there's a 330 kV line going all the way to connect to Burkina Faso. So that's the idea. And the 330 kV line too from Volta, that's Tema. There's another 330 kV line which is going all the way to Togo, Benin. That project I think has been finished. So when you have all these 330 kV lines, then you can send the power through these high voltage cables, and then when it gets to the various location, it can then be distributed. Yes.
I mean, I think your knowledge of, the system is obviously...
I spent all my life there, and that's what I try to...
Yeah, and I dare say that your work is part of the fabric of VRA, so definitely you can use me moving forward. Yeah. Thank you for breaking out showing us the power generation, capacity that we have so far. And if you see electricity within the dialectic of demand and supply, I'd like to ask, what do you think about the electricity demand requirements of Ghana from the consumer side, like you mentioned? Because research shows that around 2015, we were quite short of generating capacity, was quite short of what we needed. So could you tell us a little bit?
Before 2015, I remember very well when I was a very young engineer in 1983-84. We had a drought. Oh, yes, yeah, I'm sure you were born by then. No, you weren't born. Yeah. Okay, so we had a drought, and then you see at that time, Cosmo was the only plant, and that was the first time we had to go below our minimum operating level, so there was serious energy curtailment at that time, and this sort of happens because. And that was the first time we have to even curtail massive power supply to Vaco, because at the time Cosmo was built. At the time Cosmo was built, the demand of electricity in the country was just enough to, one machine at Cosmo was just enough to supply. Okay, but then so that Vaco was there taking the bulk. But that was the foresight. Build Vaco to take the DC, because you could not build one machine and as the load grows, you build another machine. You build it, get other people to take, and as the load grows, you add on other generation. And that was a brilliant idea at the time. So we had to curtail power supply to Vaco, the drought. And the inflow into the Cosmo lane, like the rainfall, it has some funny cycle. Like you have a number of years, like 3 or 4 years of good inflow. And then after that, you have a number of years, 3 or 4 years of bad inflow. So it goes like that. And there's a cycle like that over the years. The expert will tell you that's what it is. So during periods where we have good inflow, because we didn't have this thermal complement around those days, and even when we had a thermal complement, buying crude oil, which we didn't have, was extremely expensive. There were instances where crude oil prices were way up $140 a barrel or something. So you need close to $60 million, well, $80 million a month to just buy crude oil. And that was a lot of money to VRA. So the tendency to overdraft, that's generate a lot more from hydro when you have the water, was high. Okay, but then today is different. Today we have surplus, we have a lot of gas. We have gas coming from our West African pipeline. Yeah. We have our own gas, a lot of gas in our own gas field. So the things have changed. But as I said, along the line, there have been challenges with supply, where when we had only hydro, there was no waterfall, there was no good inflow. So then you have to curtail. Now that we have gas in other locations, 2015 that you talked about, the major problem we had in 2015 was our gas supply was from West African pipeline, West African gas pipeline through Nigeria. There was an accident in Togo where some pirates tried to hijack a ship and then the anchor broke the pipeline. We thought it could take a very short time to fix. And in the process, when it was fixed and during the commissioning of that pipeline, there was an accident which caused the lives of some people. So that took more than a year to fix. So that was 2015, 2014, 2015. And that's where Pride the World Dumsor came in, because at that time, the generation we had was not enough to meet the demand. So then you have to restore to ways of managing it. And it was tough. Yeah. It was tough. Running these gas turbines, I always tell people, on gas was excellent. It could always be available. Besides the cost of the gas, the machines run better on gas. But because we did not have gas, we built our machines which could run on liquid, like crude oil or gas. And then so like Takrady, when it was built, ran several years on light crude oil and then was converted to run on gas, because you had those facilities. But of course, when you have to run today in gas, tomorrow run on this, has its own challenges. So there were a number of problems in that switching. Exactly. 2014, 2015, we had major challenge with gas supply. And of course, the machines too, we had problems. Not to also mention that, well, whilst we were experts in running hydro at that time, the thermal machines, high speed, high temperature machines, a lot of moving parts, had their own challenges. Definitely. Okay, we had a major challenges there. So we had a lot of problem with the availability of our machines, our thermal machines. Over the years, now we've built the expertise, and today we can say we are there. One thing we never talk about is, through all these challenges of 2015, probably the government then brought in quite a number of IPPs, okay? But I think somewhere in 2003, 2002, 2003, where we had another challenge. We had another challenge then, and I remember very well in 2007, we had another crisis. Yes, we had another crisis. I remember very well coming to talk to President Kofi at that time. Yeah. We had another crisis. And that was the first time we went to the lowest ever level in Akosombo Reservoir. 2007? Yeah, 2007. 235 point. Well, we thought we could do. We went and later below 235 elevation. These machines were designed with a minimum operation level of 248. Wow. Later we went to 240. Now we went to 234.9, 5.98, thereabout. So we had challenges. But today we've learned a lot. Definitely. We've learned a lot. And as I said, Akosombo, for instance, even though it's an old plant, we've modernized Akosombo plant. And this is something that I'm very happy and proud of, because I was very, very instrumental in that project. Exactly. I worked in it as an engineer till I also became the director of that project. Exactly. One project, for instance, and after we finished the Akosombo Retreat project, based on the experience we gathered there, and based on our operational experience in the Point Generating Station, when I was the director of hydro generation, I made sure we started a project to also modernize the Point Generating Station. But elsewhere you go in the world, people build plants And hydro plants, after a number of years, you modernize it. Just like you build a house or you buy a car, after a number of years, you
Renovate.
you retrofit it. That's the word we use, and becomes like new. So those of us who were part or privileged to be part of the team who did the Akosmo Ritual project, we moved the same skills and everything to also help start the Pond Ritual project. It took some years to do the engineering, and I was really proud that I started that project as in 2014. So by the time I was leaving office, I think 2 machines had already been finished. And of course, based on our experience, we have traveled wide. We've operated this machine several years, so you know exactly what you're looking for. That's the difference. It's not somebody sitting somewhere coming to tell you it should be this, that. We've traveled in a number of countries. Hydro plants, we've gone to seminars, we've talked to people. So based on our experience, I can tell you our 2 plants, the Cosmo plant and the Pond plant, the hydro plants, they are super. They can compete with any hydro plant in the world today.
Wow.
I remember some time back, we joined some association where they were rating the hydro plants in the world. And our Kosovo plant was, I think, 2nd in the world.
Wow.
At that time.
That's amazing.
Yeah, because whatever we go and learn, we say this order we have, we might make sure is on top. And I'm proud of the engineers. I wouldn't want to call any name there. Yeah. Some of them are still working there. We make sure, and you can't cut corner. You see, I tell people in our Cosmo plant those days, when our Cosmo was the main generating station as well as bomb, when one machine goes down, those days, one machine supplies more than 10% of the demand of the country.
Wow.
So if one machine goes down unplanned, you could even get a call from the castle. You could get a call from castle. So just make sure you know what it is. So you, the plant manager, or you, the director, knows what it is. So you can explain that it is this, it's planned, this is something that we don't, beyond our listen, but you got to fix it. And I tell people, you go to work and there's a problem, you don't go home to fix it. And that's the discipline we have in our VRA. I mean, it started from Akosmo, that's where we all started. And a lot of the very senior engineers and technicians in the thermal, this also work there. So that has been a culture that, well, I think it started from the beginning. Those first engineers who started this thing, by way of training, developed that culture, and we also went into it, and that's what it is. I pray that it doesn't change.
Yeah.
I pray that it doesn't change. Because I said, well, initially we got some Canadians running Akosmo when it was built in the 60s. They left some culture with us along the line, and a number of us were also sent to Ontario Hydro. So you're always benchmarking whatever you do in VRA, not to anything in the West African sub-region or in Africa. We benchmark our operation with utilities in the developed world. And that's what has kept us. Your boss knows everything, so you better make sure you deliver to that.
I mean, thank you so much for that. It appears to me, I mean, the capacity of the VRA, it's impressive, and I'm really grateful to even to learn this, and I'm sure that viewers will be very grateful to. So I'm one thing I'd like to say is how do we reconcile? How do we improve the communication or sort of the coordination between, let's say, the work of institutions like the VRA, the government, and the people, the consumers, basically? Because I'm sure the average Ghanaian wouldn't even know how to, would not know this, or how to even reconcile that with their experience. So
well, yeah. I wouldn't blame anybody. I wouldn't blame us. Yeah. You see, Ghana started well. I always talk about the percentage accessibility of electricity in Ghana. Today we are 85, and it's growing. We're looking at the universal accessibility. Anything above 95 can tell me universal. We are looking at universal accessibility by the year 2030. I'm sure we could even achieve it before then, because every government tried to build up on that. Okay, and it all started because we had a Kosovo to start with, and a Kosovo was a hydro plant, big, cheap. Okay, big and cheap. Cheap because you don't pay for the water.
Exactly.
Okay, and hydro plants, not many moving parts. So, and supply of electricity from a Kosovo at that time was very, very reliable too. So we're used to good power, unlike some of our South-Asian countries.
Yes, like
We're
South
used to
Africa,
good power.
yeah.
Okay, we're used to very, very, very good power, reliable supply from Akosomo over the years. Because Akosomo plant, there's something we call unit availability, like the percent of time that the unit is available. Most of the time we are at 96, 98. Most of the time the machine is always available and delivering. Till we had shortfall. I mean, when you have shortfall, it becomes a different issue. Exactly. So we've been used to this. We are not used to not power not being there. It didn't start like that, like some of the neighboring countries, where power is not there, you are lucky when it comes. Here we were used to power is always there. Akosombo Kanye is always there. Okay? So when we have a situation where today this, tomorrow that, we are looking at where we're coming from. So that's where the challenge is. But I can assure you that efforts have been put in, and I think things are quite getting better today as we speak, because we have a lot of IPPs coming in. Exactly. So as we speak now, the installed capacity, the amount of generation we have today, is far more in excess of what we need. 10 years ago, our peak demand was about 1,500 megawatts. 10 years ago, 2010. 2020, the peak demand has gone up, or now the highest we've seen is 3,200, just around that. It's only just roughly doubled. Yeah. But I tell people, I'm not impressed with that. It should have been more. The 5,000 installed capacity we have today, it should have been more. Because you're looking at Ghana with a population of 30 million, and you're looking at a peak demand of 3,000 megawatts. Look at someone. I wouldn't want to talk about the African countries or whatever. You go elsewhere. I mean, go to the state of the province of Ontario alone, with a population of about 15 million. Their peak demand is close to 30,000. I mean, the peak. It could go from 20 or 15 all the way to 30.
And Ghana's is 3,000 now.
3,000 for 30 million. 10 years ago, we were 1,005. And now, well, we could do. And I believe with all this intervention, government trying to build more factories and build whatever, we should be able to move. Because the per capita consumption of your electricity reflects in your development. Exactly. And that's something that I think we as a people, I mean, we build more industries. And I believe there are other factors which could be attributed to how come we are not growing that fast. Right now, we have surplus generation. That's what we say. Because by the theory, if your demand is, let's say, 3,000, you should only have about 20% in excess, so that you don't pay too much. But there's a reason for having this surplus generation. For the problem we had during the 2015, 2014, where government had to take those bold decisions. I want to say that now because I was working, I think 25th I was the chief executive there. So some of these decisions were involved in some of these decisions. Because if you have a power crisis when the pipeline is going down, you don't know when it's going to come, and you're in 2015, the following year is election year. During the Dumsor time when power was not available, we shared as much as 800 megawatts on a particular day. The lowest we shared was 200. And if your maximum demand was 1,500, you are sharing 200, 300, at times 400. It becomes extremely difficult to manage that.
Sir, could you please explain to the viewers and us exactly what load shedding is?
Load shedding means have some level of demand and have to supply it. The supply is not enough to meet the demand. That's the customers. And if it's not enough, what do? Electricity generation says that your generation should match the demand to keep your frequency, frequency 50 hertz, to keep it there. The moment your demand has exceed your generation, you see the demand, the frequency going down. And all these machines have been set, especially the thermal machine, have been set in such a way that they operate within some fine range of frequency. So if the demand goes far more, it will send something, machine will trip. The moment the machine trips, it sends things go in different direction because of course it will also reduce your supply. So the idea, the principle where you
Intentional.
balance your supply to meet your demand, because they should meet. That's what we call load shedding. So you do it instead with that, oh, today let me take these people up, so that you want to be as fair as possible. Take these people off, and then you try to manage it. It's been quite difficult. It's been difficult. More especially because like in our area where we don't have an enclave which is fully in industries, where you can say, let me isolate the industry and give them all. You have industries here, or you have small industries along where we live. So it becomes a bit difficult. So this load shedding has been something that has been going on. And right now too, I can say occasionally you see it. Because there are problems which come. Yes. We're running a system which is not very perfect. Yes. Okay, but I'm sure with improvement, and I can say things are much better now than before because of all this extra generation that we put into the system. And so when one plant is not available, another plant is there. And luckily for us, all the plants are not using the same sort of fuel. Okay, we have a number of them. We have a hydro plant, a Kosovo pump, and then we have a thermal plants. Okay, so the thermal plants too are not using gas. Some are using HFO. Like there's an AXA in the thermal which is using HFO. So if you have a gas supply situation, they will not be affected. I know they are also working to convert. But even for the plants which are running on gas, besides the gas from the West African gas pipeline, we also get our own gas, which is quite a lot now. We have quite a lot of gas. So you're getting multiple sources of your fuel for your plant. Gone were the days where that source was a challenge. Yes, definitely. Like if it's crude oil, it's only crude oil. Yes. And crude oil, money has to be there. You have to establish your LC, letter of credit, to be able to get it. It has to be established. Money has to be there. And the crude oil has to also come from Nigeria, because our machine were designed to use light crude oil, and a very light one from Nigeria. So we will either use Bonnie Light from Nigeria, or other brand for Nigeria, Brass. Okay, and the quality of the crude oil you use also matters. So our machine could not use any other crude oil. You could only use crude oil. So when all these challenges, whenever there are also challenges in Nigeria, you know, there have been a lot of challenges in Nigeria. So whenever there are challenges in Nigeria, people in Ghana will not know that you are having challenges from getting your crude oil. Your crude oil could come, and then vanadium level, some level of sodium level is slightly higher. You might need to do some further treatment before you could even use it. You see, these are all challenges with running your machines on crude oil, and this is not done anywhere in the world. I bet you most people run their gas turbine on gas, and that is it, not on crude oil. But of course, we, in the short term, the idea run on crude oil till we get our gas. Luckily, we are there now where we have gas, so none of machines are running on crude oil. I look, as they started, when it came in an emergency, they're like car power. I'm sure you asked some question on car power. Car power also came here, and they were also running on a heavy HFO, HFO as well as AXA.
So please, what's HFO is?
Heavy fuel oil.
Okay.
So AXA still runs on that. Okay. So if you have your multiple source of type of fuel, it helps you manage your challenges. It manages your challenges. So like today we have hydro. If there's no rainfall, but because we have all these other thermal generation, it's helping us manage our thermal, our hydro much more efficiently. Not at the other time when we're running, we knew what we're doing, because what do? It could rain, it might not rain, but you still have to manage whatever. Exactly. But right now, we can manage. You run all your gas turbines on their base loads on gas, which is also available in excess in our country, and then you manage your hydro. So right now, hydro can be run in a more sustainable manner going forward. And I don't see us running into any of this problem. Right now, we have enough. We are generating, exporting to neighboring countries, which is good, but I don't believe we did not. You don't build your power plant to export for somebody else to develop. You build to develop here. Exactly. I tell people, not everybody will agree with me anyway, because if I'm going to be, it causes a lot of financial challenge because of government security and all that. So why am I building for somebody else? You are building to develop your own country. So let's forget about this. I'm exporting, net exporter. Let's develop, and when we have excess, and Ghana should be 10,000. We have 10,000 excess. We can export.
Exactly.
Okay.
That's amazing. I'm so encouraged by.
So I think we'll get there. Yeah. We'll get there. But we all have to work at getting there. The focus is to use the power here so that we can produce, turn our raw materials into finished products and send them out. Than sending whatever.
I'd like to. So how would you say, in your view, how is the progress of the Bui Dam? How have you seen the progress of the Bui Dam, and what role is it playing now, and can it play?
Bui Dam. I understand it was on the master. We had been on the master plan during Nkrumah's time.
Wow.
Well, I think the Russians were here in the 60s at that time. Okay, and I know some of my engineers who have either gone to pass in glory or retirement who worked there several years back. It was on the master plan. Wow. The master plan was Akosomu, then from there bomb, and then we others thought Akosomu, we then bomb. But then it went Akosomu, then we sort of delayed because of all these challenges with water, rainfall, and whatever. But we haven't been finished. You see, the location is also strategic because it's a generation facility we're in the north or in the middle part of the country. So it also helps in terms of support the voltage in that particular location. We, even though it says 400 megawatts, in terms of energy, it's just like a one generating station. It doesn't generate. You can only like run one machine throughout or run one machine and then pick at the evening time and run. So we is strategic and the location is also good. But of course, using hydro plants are site specific. Okay, so we at that location, you have to build. You build it. If you don't build, there's nothing else you can do. And I think an advantage has been taken to build, and I think they are doing very well. They're doing well. When they build, a few of our VRA engineers help them establish the players. We still have some of them working. But the same utility, I wish probably could also add them to VRA so that. Or I think there's still some good collaboration between we and VRA. But of course, big is beautiful, small is also beautiful. So if you add all, it's okay. If it's still on their own, it all depends on what the politicians or government thinks.
And so you mentioned a couple times IPPs and how they have like the role they've played or how they figured in our energy history in Ghana. Could you tell us a bit more about that and about the Car Powership and all the other IPPs that we've had? And just to add on to that, what is the future of IPPs?
Well, that's a nice question. But you see, because I was running VRA, I had a start, and get out by some of my previous bosses that you see, for any country, energy is very strategic. If we can, then let's try and manage that as much as we can. Now, you cannot also leave it in the hands of somebody who tomorrow can blackmail you or will want to put on strings. Okay? So the idea was, I thought, VRA as an institution to make sure that 80% of the generation mix in this country is managed by the state institution, which is VRA. I don't know whether is that now or going forward. But then the IPPs came in because money was difficult. We didn't have enough funds, and bringing on this thing, we needed the power. We needed it yesterday, and we are ready today. Okay, so then a few of them, I suddenly came in when we were also tight. I suddenly came in, and they came in at the right time. By the time they came in, we haven't challenged. And I remember the Chinese coming to meet me in Akotpa, was then the director of Hydro Generation then. I encouraged them because when power goes off, nobody knows anybody. All they know is Kirk Kofi VRA. Okay, so if a Chinese man is coming, he has his own money and they can come and help us build some thermal plants to help manage, all the better. Nobody will call your name or whatever. So we encouraged them, all right, they came in. And after they came in, others have come in. And I saw it has been a success story. So right now, they have about 540 megawatts of installed capacity and they are always available. Of course, they have their own money. They don't have to go through our process for procurement and doing this or whatever. They have the money and they can do anything they want. So their plan has been quite reliable. So they built the first one, built the second one, built the third one. All through our encouragement. Some of us encouraged them to do that. So besides that, Songwe was there. When the crisis of 2015 came, 2014, 2015 came, that's where the mild rush of all these IPPs came in. I must say at that time, it takes a lot of effort to build a power plant in developing Africa. So Mr. A comes, he wants to bring you 200 megawatts. Mr. B comes, he wants to bring you 300 megawatts. Mr. C comes, he wants to do these things. Which of them will come in time? Because you are shedding. You are shedding massively.
Seriously.
People are talking. Industry is suffering. At that time, we were $200 million or $20 million a week or something. I mean, so what do you do? And that forced government to take some of these decisions. Well, let's agree 3 or 4. Probably not all of them will pull through. Okay? But it so happens through government's own encouragement. We had car power coming in. Car power was an arrangement for an IPP to come in for 2 years and for a number of years to help us go through. Then after that, they take their ship away. That's what the car power ship. So somebody was based in Tema. Later on, arrangement was done to also increase it so that we could also take our time and see while we can also add on proper proper base units. So car power came in. Then there was the expansion of the car power. All these were done under the previous government, which was very good arrangement. So car power came in later on. SS got in, but that was foreseen. Well, one day they'll move them to Takoradi to take advantage of the SS gas in the Western Enclave. AXA came in. Amandi was built a plant which was later handed on to another one. Sempower is there, and a few of them have come in. Today we are crying that we're paying too much for capacity or whatever. But I believe some of these arrangements, when you are tired, you are shedding. You don't even know what is going to happen tomorrow. Exactly. And those people also know what it is, so they'll come and squeeze your hand in a way. But later on, I know government renegotiated some of these agreements. But you are looking at it today. If you look at some of these plants in a very long term, it will be beneficial to the country. Today, you can say you are paying 50 million or 60 million, whatever. Look at it in the long term. At the time America came in, I was part of the team that negotiated or went to that. I mean, I was in VRA, and government wanted VRA. America didn't want to have a direct relations with ECG. So America. And all we said as VRA was that, if America is coming in, because we've seen it before, when IPPs come in, like Cummins came in some time back, and generate, and after the power crisis, they take their machine away. But whoever brings his emergency plant to come and generate here for 2-3 years, by the time it takes it away, he's already gotten all his money.
Exactly.
So how this thing was for VRA, if this machine is going to, we're going to be an off-taker of America plant, then at the end of the project, the machines will be handed over to us. So the pricing of that arrangement was said that at the end of the 5 years, machine comes to VRA free of charge. And that's what it is. We are now in the 5th year. I think necessary arrangements are in place now to hand over those machines to VRA, and the government is thinking of relocating it to another location, another strategic location. Good. We could have sat there and done nothing and complained. The crisis would have gone, but would have come back again.
Exactly.
Would have come out again. So we have a few of them. But the lesson we've learned is that let's plan more long term. Plan beyond now. Let's plan. And I hope the institutions will all be put together. Not only one institution like Energy Commission who do the planning or RICO. Put all the institutions and some of the people who have also run some of these systems before in the past. Yeah. And then see how best we can plan more. I know there are long-term generations planning data reviewed regularly and see how best we can do this. But I wish that we don't leave everything in the hands of the IPP. Not everybody will agree with me. But I wish VRA, the state institution, should be the muscle. And as you speak, VRA will hold the system. Okay? So VRA, any future thermal plant, well, I think we have enough. Not as not many people will agree with me, but as a VRA man we have enough IPPs now. There are a few plants VRA has built, which government can also help to expand. So let's have that conscious effort. Because you cannot put your development into the hands of somebody. It could be an IPP. He can tell you something today. Tomorrow, he can tell because you are owing him, you haven't paid for this, you haven't paid for that, he's going to shut you down. Even China is going to shut you down. Crack, I even sent you some sleepless night.
Yes.
But yeah, I want much to go and tell government I'm shutting if government owes me. So we should be able to arrange. And of course, if VRA was not being run well, of course, I wouldn't advocate for VRA having a chunk of the generation mix of the leasing. I think VRA should be able to allow or encourage and supported by government to hold on to some of these thermal districts. Well, we have plants building thermal. I think it was finished during my time. The KTPB, the thermal plant. That site can go to 780 or 800 megawatts. Government should. So in the long term, we should be looking at that. In the long term, we should be looking at other areas where we can do. If we need another thermal generator somewhere, well, VRA can compete with other IPPs, but I can bet you VRA with the necessary government support will come first. And of course, we have other these things. We have the experience on the ground. We have the manpower and everything, and we should be able to add on the needed generation at the right time. Generation is supposed to be added at the right time. If we don't, that's what we see in some of their countries. Okay, South Africa, for instance, well, they've had their own challenge of that, where when you don't invest in the system, it will catch up on you one day. Okay, Nigeria has their own challenges. Neighboring countries have their own challenges. Ivory Coast, you don't hear too much because there has been consistent non-interference by government or whatever support for the power system. So that's one thing I encourage, that the power system itself, let's look at it holistically. Pricing. People think price of electricity. Price of electricity should be very, very, very competitive. I don't see it now. It should be extremely competitive because you're going to buy a particular product which is being produced somewhere at half the electricity, okay? And a lot of these products, production lines are, energy intensive. Yes. So we should be mindful of that in our pricing mechanism. We should be mindful of that. It's then individuals, but our domestic electricity tariff here are way high. Exactly. Look at a country where 30% of our generation is hydro, and you want me to pay far more than other countries where they don't even have hydro. Everybody should benefit from that. So our pricing mechanism of our electricity should be looked at. If in the past, as you see, we started from a different angle where it was all hydro. So the pricing was said that, well, it's like this. Right now that today, as we speak, thermal is about 66% and hydro is about 33%. Okay, so you can see the balance now. Several years back, it used to be about, 10 years ago, it used to be the other way around. Yes. But today, thermal is more. So anything, we should be able to look at it in a way. And things are becoming a bit more competitive now in the industry. We are not the only people in the industry. So we should be able to squeeze the IPP to make sure we get the right tariff. Once the money want to stay here, we should be able to squeeze them.
And just as I wanted to find out, so hydro and thermal, which one would you say is maybe cheaper?
Oh, hydro is extremely cheaper.
Yes, of course.
Well, Bui is even cheaper than thermal. Okay. Yeah, Bui is about 10 cents or something. Because of hydro, they tell you the textbook value is about between 2 and 3 cents. Okay. Because of course you build the plant. Well, you don't buy crude oil. The water is there. You don't pay for the water. We don't pay. Of course, if we're paying for the water to the government or something, that's a different issue. So hydro is relatively cheap and safer. And more environmentally, well, the environmentalists will also argue with you on that. But
so I'd like to ask, so if you had the ear or you have had the ear, what would be your top 3 things or measures that the government or any government could take to support the energy system as it is now in Ghana?
Well, let's look at our future planning. I think it is there. Right now we have it. Because we have surplus today, we should not just sit down on that.
Can we store?
No, you can't store. So because we have surplus, that's why we're also exporting. Yes. We should encourage the use efficient and efficient use of the electricity, one, and then also see how best we can also add on. Where I said 30 million and
Yes,
3,000,
3,000.
no, it's a
Definitely.
non-starter. It's not.
Definitely.
We should be able to go way beyond that. So government have been very, very supportive, extremely supportive. That one I cannot from all government, because like all the VRA thermal plants is government funded.
True, as you
Yeah,
say, it's a
government funded. I
institution.
mean, VRA is a government institution. It's all government funded. I mean, it's not VRA who went somewhere.
Yeah.
Except the complaint that VRA had to go and borrow money from Fidelity on his balance sheet and pay. But the rest of the plants were all government provided and whatever. Or we go and take loan, government does the guarantee. And so government have been very, very supportive. I can say that I can say government have been very supportive, and I will encourage successive government to also support. But then let's be looking more into the future. The future, how can we add on? What else do we need to move beyond where we are now? 5,000 megawatt installed capacity, which we're way beyond that, which the big demand right now, we're around the 5,000, moving to the 10,000. But of course, well, our neighboring countries, they are nowhere near that.
And speaking of adding on, how would you say renewable energy? What's the future of renewable energy in Ghana?
Renewable energy is the future of the world.
Of the world, definitely.
That's what everybody says. It's true. Crude oil is finishing with time.
Exactly.
I remember when I was a young engineer in Canada working in one of their big. That time I worked in 1988-89. I worked in Nantico. That plant was one of the biggest thermal plants using coal fired. What happened? Today that plant has been mothballed, it's shut down. Nobody's using coal in the developed world. I mean, China and other places are using. So some of these resources will be split, but the sun is there forever. So that's the future. But there should be an effort to match it properly.
Exactly.
Right now, we have VRA built a 2 megawatts solar, added on to another 15. I just heard recently we have added on a 50 megawatt solar. Solar is okay, wind is okay, but it should be done properly, because you don't want anybody, because that's the future, everybody's coming. If it's done properly, regulated and managed, it can also pose a problem.
Exactly.
I remember going to Spain one time when we were going to build our solar plant. I went with the then chief executive and a few engineers. Well, you have to manage. They had a time where their renewable generation was more than their at the particular bet. It can also bring some instability in the system. So all this you have properly coordinated. Our policy as a nation is to have 10% of our generation as renewable. Let's have the roadmap and like who is doing what and at what time, and that is it. Price is very important. Gone were the days when solar was more than 10 cents. Today you could get solar less than in Dubai. Solar in less than 6 cents. Wow. So we should be aiming at single digit cent for solar or any renewable generation. Because the price of electricity, as I said today, in Ghana is high. It is high. Because if I look at how much I pay for electricity in my house, a similar house in America or whatever, will be paying less. But the same money we are using to pay. So we should be able to drill down into some of these areas to make sure we get the right pricing for these products. Renewable is the future. I mean, we have vast land and areas, rocky areas where it cannot be used for anything else. There are these solar panels which can float on the lake. Definitely. These are all technologies which are coming up. Exactly. So I think there have been discussion, and I think there should be the encouragement for people to come in. If there are people who want to shift in that area, probably that's also a good area. Good area.
Sounds great.
For a 3,000 megawatt, if we think 10%, so you look at 300. So we should be able to get there quicker, and then probably change from the 10% to 15 or even to 20. So long as we have the resources to do that. When it is there, if you use it, you use it. If you don't use it, the wind blows today, it's blown and it's gone. The sun comes today, it's gone. But the energy you could get out of it is gone. So we might as well look at it. That is the future in the developed world. So I believe that's also the future for us here. Because hydro virtually finished all our hydro. Now we're going to build Pualugu. Pualugu is a very small plant. It's not for the energy or the power that we want. It's for the irrigation and plant control. Exactly. All the hydro sites on the lower, in the Pra and whatever, down south, environmental consideration, you want to be very careful because these are very agricultural and well habited places. So you want to be careful while you want to go and dam the pra or whatever. And no, so those areas, I think we can let them stay for now and look at the renewable, which we are blessed with the sun, we are blessed with the wind in Anglogan. And I must say, VRA had done a lot in those areas, done a lot of wind studies along Anglogan, Geta, at that area. So the data is there. Energy community also have some data. And there are a lot of sites. So I believe IPPs could come in, government could come in, the international community who can also want to also help us to cut back on fossil fuel fire plants can also come in and help us with all these things.
Yes, I think that's a remarkable plan for the future. Thank you so much, Engineer Kofi, for explaining in such detail, great detail, like the Ghanaian energy ecosystem, taking us through the history, the technical considerations of generating power in Ghana, you letting us know about different plants, like even the palm plant, which I hadn't heard about. It's been great, and I've learned so much, and I'm really grateful for speaking to us today. Oh, PDF. I was, and maybe you could tell us something about that, the PDS.
Well, yeah, you see, for a lot of us, well, I don't know whether it's a question of communication.
Exactly.
Now, the idea behind PDS through bidder was excellent. ECG, if your losses in ECG was, let's say, even 30%, it's not, let me not put figures there, it's above the industrial average, yes, or what is internationally accepted.
Exactly.
And you want to bring somebody in to help you achieve that. That's an excellent move. Okay, so the idea of bringing a third party to help manage ECG was to help ECG move from wherever they are today to a better position. It's not that they were not doing too well, but they could move because the losses in ECG and the challenges we face in ECG could be better improved if perhaps somebody came in. Probably the process might have flawed, probably. So that outcome came. Because as I said, gone were the days where bulk power generation was hydro. So you can afford a slack where there's so much loss.
Yes.
You could. Not that it's good. But then if you're spending 60% of your generation is thermal, which is extremely expensive, and so much is going as losses, which can be reduced. Anything that you can do to reduce it to a 4, a 1, or even 10%, mark improvement. So I believe the idea was good. Because I'm with energy, I tell people, nobody sees electricity. Yeah. The same thing. Exactly. And the way electricity is produced in the UK, Canada, or whatever, the same way it's produced here. So if they are doing A, B, C more efficiently, and we have the resources and the men to be able to move to that level, excellent, we should be able to do that. So I believe the idea is okay. I'm sure if there's a way internally for ECE, they can also do a restructuring and government with government support. So we do the right thing. Because I believe we have the money here. But if VRA has been able to do all these things over the years, I can't say that we are 100%. But we want to benchmark our operation with international people in the US. I mean, we went to all those seminars. We joined that association, and we send them data from our hydro plants to benchmark our operations. And I can tell you, but for the number of people who work in our plant, we would have talked. Like, okay, we had a lot more people. But of course, our situation is a bit different because we do everything from cleaning to everything. So I believe, I wouldn't say I can't say we are doing bad in the energy sector. I'm not going to also compare ourselves with our sub-region, which we compare ourselves to the developed world, but that's where we want to get to. If we have plants which are running like plants in the developed world, we should be comparing our energy sector. And I believe we're on the right track, but a lot more will have to go in. And there should be somebody keeping an eye on that so that we don't deviate. But when you deviate, Dumsor could come back. Exactly. But Ghana should also understand slight challenges in power supply, but of course, it should be communicated to the people to know that, tomorrow we have this challenge, or when it happens, it should be because right now, social media, it's easier to send information around.
Exactly.
And when that is done, people will also appreciate that challenge.
Exactly.
So let me also thank you very much.
Definitely, definitely.
I hope I've been able to explain myself
Definitely.
or to educate our listeners as to what it is, and I'm always available. Yeah.
I think definitely communication is key, and I would ask if somebody is trying to find out more information about VRA or about the energy system in Ghana, do you know any resources they could go, or maybe the general internet, the Google is their friend?
Well, let's try that. If it's not, you could go to VRA itself, go to the VRA website or GRICO website. I'm sure there should be enough information, or Energy Commission website, there should be enough information there. Or you could also go into VRA and say corporate communication people.
Exactly.
I mean, somebody should be able to get some information on these things.
Yeah. And as a distinguished engineer, what would you tell an up and coming mechanical engineer or engineer who's trying to, work and contribute to Ghana, to Ghanaian energy system, or maybe to VRA? Or
what I tell people, we're not able to want that. But we live in a different world today. The engineering profession is not to make yourself, you the engineer, happy. The profession is to make other people live comfortable. That's the profession. If you want to go make money, you're in the wrong profession. Because you're going to produce the air conditioners, you're going to produce the cars, you're going to produce these. You might not probably even afford that. But you have to make sure those facilities are there and running efficiently. So that is the difference. It should be work first. It should be work first and should be dedicated. And I mean, I've been to the States several times and seminars and work in their plants and whatever. And you meet the professionals there, they are very professional. They look at the job and it's their job. You work and the pay comes as whatever. We don't even think. I mean, that's what I tell people. In the VRA, at time, probably now too, you go in the work, you have a problem with your boss or something, let them be a problem in the plant. You forget about your problem, you solve the problem before you even go and talk about it. If your promotion is delayed and so on, probably it's important, but you solve the problem. And that should be the attitude. Work first, and should be very dedicated and committed to it. And engineer, yours is to make other people comfortable and happy. And that's the profession you've chosen. And for the upcoming, I think it's a fulfilling profession. And if you want to practice it well with good people who would nurture you and you listen to them properly, you definitely enjoy it. I've spent all my life in VRA. No single minute of regret. I've really enjoyed working in VRA. By virtue of my age now, I can't work there again, but it's been good. Yeah, and I'm most thankful to all past head of states and government who also helped me. Because when you are there, you meet all these people. Anyway, you meet all these people, and their words of encouragement also encourage you to even do more when you are there, and that's very important to all of us.
Thank you so much, and Ghana is definitely grateful for your service. Thank you so much, Engineer Kirk Kofi, for being here with us today. It's been amazing. Thank you.
Thank you very much. And to end, one person I would want a single as President Kufuor. One time, he noticed my performance and achievement in VRA and awarded me with the Order of the Volta.
Amazing.
I never expected it because I was working with a team as a leader of the people, and he was able to see from where he sat. And I think I'm most grateful. That's one honor I think I'm most grateful because he came to me as an individual, but to VRA as an institution. And I think I'm very happy about that. So thank you very much for probably giving me the opportunity to share a little bit about what we do, what VRA does, and what I've also been able to go through in life. So thank you, Mr. Leadership team.
Thank you so much.
Good. I hope I've been helpful.
Yes.
Okay, right. Okay.
Thank you.
Okay, right.